Hello friends. Yesterday in online session we discussed about the condition for constructive and destructive interference, right? And we know that for constructive interference path difference is n lambda and phase difference is 2n pi. For destructive interference path difference is n plus 1 by 2 into lambda or 2n plus 1 into lambda by 2. The phase difference is 2n plus 1 into pi. So friends, you have to remember path difference and phase difference for constructive and destructive interference, right? Now today we discuss about the formula of path difference in Young's double slit experiment, right? The question is like this: obtain the formula of path difference at a point on the screen in Young's double slit experiment in term of x, small d and capital D, right? Or the question is like this: prove path difference is equals to x into small d upon capital D, right? So the question are asked like this. Now we discuss about the formula of path difference, right? Now see here, this is the slit S, right? Now this is the slit S1 and this slit is S2, right? Having a same distance from S, right? This is slit S, this is S1 and S2, right? Now the slit is denoted by like this. This is slit S, this is S2 and S1, right? Now here this is the screen, right? Screen, right? Now here we assume that the distance between this slit S1 and S2 is small d. You have to assume that the distance between slit S1 and S2 is small d. The distance from these two slits from this screen is capital D, right? Now the wavefront emerges from slit S, right, and incident on slit S1 and S2, and this wavefront incident on S1 and S2 at same time. So here we can say that S1 and S2 are the coherent source, right? So here we consider a wavefront like this, right? This wavefront incident on S1 and S2 at same time. So we can say that this S1 and S2 are the coherent source, right? Now here we draw a perpendicular bisector from S1 S2. So here this bisector meet this screen at point here. This is the point O. Now suppose the interference obtained at point P on this screen, right? So here at some point here P. So here the interference is obtained, right? So here we connect S1 to P and here S2 to P. Okay. Now here we considered that the distance between O to P, this distance we assume this is X, right? Now we have to find out the formula of path difference. So here S1P and S2P, right? So the distance from S1 to P is S1P and S2 to P is S2P. So we can say that the path difference is S2P minus S1P, right? So we have to find out the formula of S2P minus S1P, right? So to find out this path difference, here we consider that this is D. So here, as we connect this point to the screen, so here and here, so this is point M and this is N. Now here the distance between S1 to S2 is small d, so M to N is also small d. So here this distance is d by 2, right, half, and this distance is also d by 2, right, because distance between S1 to S2 is small d, so distance between M and N is also small d. So here the distance between M to O is d by 2 and O to N is also d by 2, right? So if we have to find out the distance between P M, right, so see, the distance from P to O is X and distance from M to O is d by 2. So the distance between P to M, this distance is, we have to subtract d by 2 from X, so X minus d by 2, right? Now if we have to find out the distance between P to N, so this P to N, see this distance, so this is X, P to O, and O to N is d by 2, so this distance is X plus d by 2, right? So here we find the O distance, right? Now we can write that, so wavefront emerging from S and incident on slits S1 and S2 at same time, so this S1 and S2 are coherent source. The distance between S1 and S2 is D. The screen is placed at distance capital D from perpendicular bisector of S1 S2. You can see that here the interference obtained at point P on screen, and we have to find out the path difference S2P minus S1P, right? So here we don't know the value of S1P and S2P, right? So first of all we have to find out the value of S1P and S2P, right? So to find out S1P, see this triangle S1MP, see S1MP, right? So here we can use the Pythagoras formula, right? We know the formula S1M square plus MP square is equals to S1P square, right? So I repeat, to find out S1P we have to consider the triangle S1MP. So by using the Pythagoras formula, S1M square plus MP square is equals to S1P square. We know the value of S1M, capital D. Value of M to P, this value is X minus D by 2, right? So we use the Pythagoras formula, right? So from the figure, in triangle S1MP, right? In triangle this S1MP, we use the Pythagoras formula, so we can say that S1P square is equals to S1M square plus MP square. So S1P square is equals to S1M, we know S1M is capital D, so capital D square plus MP, the distance from M to P is x minus D by 2, right? So x minus D by 2 whole square. This is our equation number 1. Now to find out H2P, see this triangle H2NP, right? See, right, H2NP, right? So from triangle H2NP, again we use the Pythagoras formula, H2P square is equals to H2N square plus NP square, right? So H2P square is equals to H2N square plus NP square. So H2P square is equals to value of H2N, capital D, so capital D square plus N2P, N2P, this distance is x plus D by 2, right? So x plus D by 2 whole square, equation number 2, right? Now we have to find out the value of path difference H2P minus S1P, right? So to find out the path difference H2P minus S1P, see, we know the value of S1P square and H2P square, so we subtract equation number 1 from equation number 2, right? So from equation 2 and 1 we can get H2P square minus S1P square, right? So first of all we have to write down the value of H2P square, so the value is D square plus x plus D by 2 whole square, right, minus S1P square, so D square plus x minus D by 2 whole square. Now we know the formula of this is a square minus b square, right? So we know that a square minus b square is equals to a plus b and a minus b, right? So we can write that H2P minus S1P, a minus b, then a plus b, so H2P plus S1P, right, is equals to this d square as it is. Now a plus b whole square, right? This is the formula of a plus b whole square. So we know that a square plus 2ab plus b square, right? So a square means x square plus 2ab, so 2x small d by 2, right? 2ab plus b square, so d square by 4, right? Now minus this equals d square plus, see, this is the formula of a minus b whole square, so a square minus 2ab plus b square, so a square, so x square minus 2ab, then x into small d by 2 plus b square, that means d square by 4, right? B square. Now here we take negative sign inside, so we get H2P minus S1P, H2P plus S1P. Now this d square plus this is as it is x square plus here 2 cancel, so xd plus d square by 4. Here again 2 cancel, so here as we take minus inside, so minus d square
then again minus plus minus x square, then minus minus plus, so plus xd, minus plus minus d square by 4. So here d square cancel, x square cancel, d square by 4 cancel, so we get xd plus xd, right? So we get h2p minus s1p, h2p plus s1p is equals to xd plus xd, that means 2xd, right? Now here we have to find out the path difference, h2p minus s1p, right? But here the distance x and small d are very small as compared to capital D, because capital D is the distance between two slits from the screen, right? So here capital D, the value of capital D is very high as compared to x and small d, right? So here we can take the distance from s1p and s2p is capital D, right? Again I repeat, see here this value, the distance between two slits, you have to remember that the distance between two slits, I mean s1 and s2, this distance is always in millimeter, right? So the value of small d is very less. Here the distance between O to P, this x, this is very small as compared to the distance between two slits from screen. So here the x and d are very small as compared to capital D. So to find out the path difference, we can take that S1P and S2P are nearly same. So we can take S1P is equals to S2P is equals to capital D, right? So we can write that here x and small d are very small as compared to capital D. So S1P is equals to S2P is equals to capital D. Hence we have to find out the path difference, right? So see here, this S2P minus S1P, here we have to find out the path difference. So this S2P minus S1P remains same, but here S2P plus S1P, so here we have to put S2P is capital D, S1P is also capital D, is equals to 2xd. So the equation is like this, S2P minus S1P into capital D plus capital D is equals to 2x small d. Okay. So we can write that. Hence S2P minus S1P capital D plus capital D is equals to 2x small d. We have to find out this path difference. So S2P minus S1P is equals to 2x small d upon d plus d 2d, as we take this 2d to right hand side, so divided by 2d. Here 2 cancel, so S2P minus S1P is equals to x into small d upon capital D, right? So friends, you have to remember that path difference between S1 and S2 from point P is x into small d upon capital D. So we can say that hence the path difference of S1 and S2 from P is equals to x into small d upon capital D, right? So friends, you have to remember this formula
for Young's double slit experiment, the path difference is x into small d upon capital D. Right? Now, suppose for constructive interference, we know that the path difference is n lambda, right? So, to find out the distance from point O to point P for constructive interference, so we have to put S2P minus S1P is n lambda, right? So, the condition for constructive interference, right, and this condition is for Young's double slit experiment. So for constructive interference, S2P minus S1P is n lambda, right? We know that, where n is 0, 1, 2 to infinite. So we can say that n lambda is equals to x into small d upon capital D, right? So we can say that x is equals to n lambda capital D upon small d, right? N lambda capital D upon small d, right? For nth number, so we have to use the xn, right? So we can write x or xn. So you have to remember, for constructive interference, xn is equals to n lambda capital D upon small d, right? So this is the condition for constructive interference. Now for destructive interference, we know that the formula is 2n plus 1 into lambda by 2, right? So for destructive interference, again we prove the formula. So now for destructive interference, right? So we know that for destructive interference, path difference is 2n plus 1 into lambda by 2. So S2P minus S1P is equals to 2n plus 1 into lambda by 2. So instead of S2P minus S1P, we have to write down here S2P minus S1P. We have to write 2n plus 1 into lambda by 2. So 2n plus 1 into lambda by 2 is equals to x into small d upon capital D. So xn is equals to 2n plus 1 lambda into capital D upon 2 into small d, as we formulate x, right? So xn is equals to 2n plus 1 as it is, lambda by 2 as it is, capital D and small d in denominator. So you have to remember that. Again I repeat all the formulas. For Young's double slit experiment, path difference is x into small d upon capital D. For constructive interference, xn is equals to n lambda capital D upon small d. And for destructive interference, xn is equals to 2n plus 1 into lambda capital D upon 2 into small d. So you have to remember this formula. These formulas are useful in the examples. Okay, thank you.